friends, in this video I'm going to explain you about the number system. It is very important to understand about the system of numbers. The way we have systems in many other fields like solar system, like we have digestive system. Likewise, the system which is filled with numbers is called number system. So here let us try to understand what type of numbers we are going to have under this system. So everyone knows about natural numbers, right? I'm beginning with the most basic type of number in the number system, which is natural numbers. Natural numbers. Why these numbers are called natural numbers? Because whenever we start counting any object or anything, we manually it comes out as 1 2 3 4 5 6, isn't it? So that is why the thing which naturally comes out are called natural numbers. So 1 2 3 4 and so on are natural numbers. Now the next set of number is whole number. Whole numbers. Whole number is a set of numbers which is just greater than the natural numbers. There is only one addition of extra number, which is 0. Or we can say whole numbers are nothing but the natural numbers along with 0, we can say. So 0, 1, 2, 3, 4, 5, 6 and so on is the set of whole numbers. The only addition in natural number is 0. With natural number is 0. So these are whole numbers. The next term or next type of number which is important for us to understand is integers. Now in integers there are two type of integers. One is positive integers and the other is negative integers. Now the thing is, what does it mean actually? Positive integer is nothing but all positive numbers like +1, +2, +3, +4 and so on. Negative integers nothing but -1, -2, -3, -4 and so on. And basically the most important thing in understanding this is the denominator of the number is 1. Here also denominator is 1, here also denominator is 1, here also denominator is 1. If nothing is written under the number, by default it is 1. So these are the numbers which comes under integers, positive integers and negative integers. Now are you getting any question in your mind? Are we missing any other number? Are we not focusing on any number which is left out? Yes, that is 0. What about 0? Where it will come? Whether it is a positive or negative integer? 0 is not a positive integer. Why? Because 0 is null. It is not something positive, isn't it? Neither it is negative nor positive. So 0 is also included in integers along with 0. All positive integers, negative integers along with 0 is the set of integers. And here also if you see, there is nothing in the denominator, that means upon 1, denominator is 1. So 0 is also an integer. Now the next term which is very important in this chapter is rational number and irrational number. So here first we will write rational number and we'll see what type of number are they, rational numbers. Rational numbers are the numbers which can be written in the form of p by q, where q is not equal to 0. Any number which can be written in the form of p by q where the denominator is not equal to 0 are called rational numbers, while the numbers which cannot be written in the form of p by q are called irrational numbers. Now here another important thing to understand is the decimal expansion of rational numbers and irrational numbers. About decimal expansion, if we try to understand, the decimals which are terminating The decimals which are terminating, for example 3.2, terminating means which ends, which stops somewhere. So 3.2 is a decimal expression, a decimal expansion which is not having endless numbers after point, right? 3.2, or be it 1.256, okay, or if I write only 7, that's it, 7, there is nothing after 7. So these are the examples of terminating decimal expansion, and this comes under rational number, because in some way or the other way these numbers can be written in the form of p by q. Here 7, only 7 is there, in denominator 1 is there, so again it is in p by q form, isn't it? In my next video we will also see that how to convert any decimal expression in p by q form. So here I have just given an example, and in this video I am giving you a brief idea about what is there in the number system. So the numbers which are terminating in nature are rational numbers, and there is one more property which is non-terminating but repeating. Non-terminating but repeating. What does it mean? Non-terminating but repeating means what? Suppose I divide 10 by 3. It is in p by q form. What will be the answer for this? 3.333. Again and again I'll keep on getting 333. What does it mean? It means that dot 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 means what? 3 I'm getting again and again. That means it is non-terminating. There is no end to it. But repetition is there. 3 is being repeated again and again after the decimal, isn't it? So such numbers are called non-terminating but repeating in nature. Be it 60 by 3, it will be 2 point again 3333 dot dot dot. And for the repetitive digit we can also write them as 2.3 bar. These things will be useful in my next video to understand the representations. That's why I am giving overview of it. And now let's see the decimal expansion of irrational numbers. So here irrational numbers, here it is again nothing new. Here we just saw non-terminating but repeating, and here the only difference will be on this part. The numbers whose decimal expansion, no, because actually they cannot be written in p by q form. So any decimal expansion we can say, because there are few notations for which such decimal expansions are defined, but they are not in p by q form. So I would better say such notations like pi, like e, like log of any number may give us such thing. So it is in that way. So irrational number is what? The decimal expansion which are non-terminating and non-repeating, or we can say non-recurring. Another term for repeating is recurrence, recurring, I may write, or repeating. Similarly, non-recurring, non-terminating and non-recurring decimal expansions are also called irrational numbers. So here also let's see a few examples. For example, 1.27195 dot dot dot. What does this 3 dot indicates? It indicates that some or the other numbers are again and again coming, but what is their nature? It is different. The digits, the numbers which we are getting one by one are not repetitive in nature. Like here we have seen 3.33333, again and again we will be getting 3 only, and in this case also 3 only. Likewise in some case only 5 I am getting, suppose. But in non-terminating, non-repeating decimal expansion means 1.27195, means all digits are different, or there is no set pattern of repetition of the numbers. Or I may also give example of this: 2.101100011010 dot dot dot. Again here I can say there is no such a systematic or same pattern of repetition. There is no such repetition, although 1010 is visible, but they are not being repeated in a specific way, specific pattern. So for example, if I consider example for this case, rational numbers case, I may take example of this, like 2.101010 and so on. So here I can see 101010. This is set of pattern which is being repeated again and again, so it will come under non-terminating but repeating rational numbers. Okay, and in my next video I will teach you how we can convert such type of numbers in P by Q form, which is very important and it comes in exam. So this is what all about this concept. See you in next video. I request you subscribe it so that you get to know about the next video which is formed. Thank you.